yesterday, we had written on the board y equals 1 over x. And then we really had not enough time to graph it and talk about it, so I just said let's hold off. So graph that on your calculator. While you're doing that, I'm going to get this opened up. There we go. So when we graph that on our calculator, we get this graph. Okay? And so it looks something like this. Do we agree with that? Yeah. Okay, that's what it looks like. So what's happening right here? We have an asymptote going on there, don't we? Okay? That's an asymptote. It is right there. Okay? And where's it at? Okay, where x equals 0. If we look at this, what do we notice? X is the denominator. What happens if x is 0? What's 1 divided by 0? Okay. It's undefined, right? Can't divide by 0. And so when the denominator is 0 there, I end up with this asymptote, don't I? All right, let's look at this one. Y equals 1 over x squared minus 4. So let's graph that one. X squared minus 4. 1 over x squared minus 4. Write down on your paper. A-S-Y-M-P-T-O-T-E.
Just click on the 3.
It is. A-S-Y-M-P-T-O-T. Oh, I'm sorry. So my graph looks something like this now. If your graph doesn't look like this, you probably didn't make sure your minus 4 stayed in the denominator. Okay? So you either have to use the fraction option or use parentheses to make sure it stays down there. The way it was drawing on my screen when I did it, I thought it was going to be okay, but then it wasn't. So you have to make it be okay by either using parentheses or go to here and choose fractions. Okay? So, let's go back. Escape. There we go. Again, I don't have time to mess with that calculator. It doesn't work well with the computer running. But we have something like this. And then we have something like this. Did this one actually come up into here?
No.
Okay. So it's down here somewhere? All right. So it looks like that. Now, what's happening then? What's happening is we have something that looks like this. going on. We have two what? Two asymptotes going on there. Where do they occur at? 2 and? Go ahead, Brett.
Yeah, -2. Would there be another one, like on the x-axis?
Yeah, we're not worried about those today. Okay. We will worry about them eventually, but not today. Couldn't hear that at home. He's saying, isn't there another one right here? And you're right, there is. Okay, but we're not worried about that one. So, today we're just focused on the vertical asymptotes. All right, meaning the values that x cannot equal. So if we look up here, look at this, x squared minus 4, that's the same as, if you remember back to factoring difference of squares, 1 minus 1 plus. What kinds of factors are those called? Conjugate factors. Good. They're conjugates. They're same numbers but different signs. This is a perfect square. This is a perfect square. And we have the difference of them. Okay? And so we end up with minus 2. X minus 2 gives me this one. X plus 2 gives me this one. Okay? Meaning x cannot equal 2. X cannot equal negative 2. Right? So we have two asymptotes there. All right? Okay, next one. Once you graph this equation, y equals x plus 2 times x minus 1 over x minus 1. Now, in this case, x minus 1 on the bottom is not in parentheses, but don't be afraid to put it in parentheses. Whenever you have binomials like that and you're multiplying, dividing with them, you need to realize they stay together. And so write this down, Brandon. Write this down on your paper. Use your calculator and graph that. I'll see if my calculator is responding now. So when you graph on your calculator, do you agree you get this? Okay. We get this line looks like this. And so let's go to my notes. So that graph looks like this. Right? What's not true about this? There's no asymptote. That is true. There's something wrong with this graph. The calculator is ignoring. It is a linear graph. But what can't happen in this picture? What can't happen? Okay, my denominator can't be 0. Right now my denominator is x minus 1. So we're saying x minus 1 cannot equal 0, which means x cannot equal 1. So when I go over here and I look at my graph, there can't be anything there. So we have to have a hole at that point. The calculator doesn't acknowledge it. What the calculator is doing is they're saying this and this are the same. Why it doesn't acknowledge, I don't know, because that calculator is way smarter than I am. But sometimes it just doesn't show you the whole picture, and you have to be aware of that. Okay? So because that denominator is x minus 1, if I put 1 in for x, I would be dividing by 0, and that's against the rules of math, isn't it? So you have to be smarter than the calculator there. You have to say, you may not be smarter than a 5th grader, but you have to be smarter than a calculator. You have to say that x can't equal 1. So on my graph at that point, I have to have a hole. Okay? Have to have a hole. I want you to look at this one. Whoops. Add a new page. I want you to look at this one. Y equals x plus 3, x minus 1 over x plus 3 x plus 1. And type that in your calculator and work it out. Pause while you do that. If I'm right, you got something that looked like this.
No. It's opposite. It's opposite.
So you're saying
The one on your
this is
right
down
crosses.
here?
No,
No.
like
One
turn
on
your
your-
graph. One on your right
Like this.
crosses.
You can just turn it right over. Yeah, there you go.
There.
Here you go.
Yeah, here we go.
Then you still have to slide it up and no, yours like
It crosses like the ones on both of them.
right there.
Yeah, there.
Right
There.
there. Nice.
Okay. Thanks. So you got something that looks like this. What do you think's happening here? Okay. What else is going on here that's not in your picture? Where? Brett?
-3.
-3 and
-1.
-1. Well, what's at -1? The asymptote. And so what you're saying is, right here, there should be a hole, shouldn't there? Yay or nay? Yay! Okay, good. Now, what I want you to do, I want you to look at all of your pictures and try to devise a summary of what's happening. How do I know when it's an asymptote? How do I know when it's a hole? Okay, so if you go back through all your graphs, how do you know when is it going to be an asymptote? When is it going to be a hole? Talk it out with you. Okay, quiet please. Let's thank you for A, staying on task, and B, making an effort to talk this out. Let's come together and bring our conversation together and see if with my direction, if we can't come up with what's really important here. So, Jocelyn, you were willing to jump into a reason before. Can you give me what your group was talking about? Can you just tell me what your group was coming up with?
If there's an X in the denominator.
Okay.
Okay, so if there's an X in both the numerator and denominator, then it's gonna have a hole. If there's just an X in the denominator, it's an asymptote.
Okay. I'm just going to modify a tiny bit. The concept that she's saying, let me say it out loud so those at home can hear. She said if there's an X in the numerator and denominator, it's going to be a hole. If there's an X in only the denominator, it's going to be an asymptote. That concept is exactly correct. The wording you're using is just a little bit off. I don't think we want to say if there's an X. What do we want to say? No? That's the same as X. Yeah, go ahead.
If it equals 0, the denominator equals 0.
Okay?
If it can be, if it's
If it
back
can
in
be
it.
So if you create a 0 in the bottom, right? Only in the bottom, it's a what?
asymptote.
And if it's a 0 in the top and bottom, it's
Hole.
a hole.
There's 0, 5,
That's right. So if they have the same 0, if the top and bottom have the same 0, then that makes it a hole. If only the bottom has that 0, that makes it an asymptote. Okay, so we want, I'll just start a new page. We want to put this in words. So a hole occurs. Did I spell occurs wrong?
Yeah, it's with an O.
Yeah.
Oh, yeah. That, I knew something looked wrong, but that's not where I was looking. I was actually looking at the R.
I think it's double the C, double the R.
Okay. That's what I
Maybe-
wondered.
Maybe it's just an I.
No,
I
it's
know, right.
OCCURS.
I think that's what
So it's right now?
Yeah.
Hole occurs when? The hole occurs when what?
When the both numerator and denominator.
Okay. I'm going to make it shorter. Both top and bottom have the same 0, right? When both the top and bottom have the same 0, that makes a hole. An asymptote occurs when what?
When the bottom has
When only the bottom has when only the bottom has the 0. Okay? So when you look at an equation like y equals x plus 1 over x plus 1 x plus 2, what are you going to say?
it's just an asymptote. There's a hole.
There's a hole where? At -1. And there's an asymptote where? At -2. When they have the same 0 at -1, it creates a hole, right? When the top and bottom have the same 0, it's a hole. So this hole is at -1. So your response should be hole at x equals -1, asymptote at x equal -2. Right? That should be your response to that question. And so if you understand what this graph looks like, I'll draw a little bit of an angle. So it looks kind of like this.
Would there be one?
Oh, sorry. And then at -1, we're going to have a hole there. So that's what my graph's going to look like.
Would there be an asymptote
At -2.
at the x-axis?
Yeah. These would, there would be. There would be. But again, we're not worried about that right now. We're just worried about the vertical asymptotes right now. We're worried about, actually the unit we're talking about is points of discontinuity, and holes and asymptotes are points of discontinuity where there's a break in the graph and it doesn't exist at that one point, and that occurs when the bottom becomes 0. Okay? All right. Any questions on this? Okay, then I will upload this in addition to the notes we've already uploaded.